Hi class, my name is Lila Ford and this is my Teach One for HAP 671. It's on the topic of evaluation of SQL predictions. So we'll be going over sensitivity and specificity, the purpose of the receiver operating curve, the naive Bayes formula, and then some SQL code for this week's team assignment. So sensitivity is how accurate predicting the presence of a condition will be. The higher the sensitivity, the more accurate the prediction will be. It's found by the true positives divided by the total number of true. So like this value divided by this value. Specificity is the accuracy in predicting the absence of the disease or condition. High specificity means not mistaking other things for the condition. And it's found from the true negatives divided by the total absence of the condition. The receiver operator curve plots the sensitivity and the specificity at different cutoff points in order to predict the ability for an accurate prediction. So this graph right here shows the receiver operating curve, and you can see the different cutoff values. On the x-axis, it has 1 minus specificity. On the y-axis, it has sensitivity. This line right here represents the random prediction line. And the area in between this is called the area under operating curve. It shows how much the sensitivity and the specificity of the predictive model is better than a random number. So a random prediction would have an area of 0.5, and a perfect prediction would have an area of 1. So how much greater than 0.5 the area of the operating curve is means a more accurate prediction. So this slide here is the naive Bayes formula. It predicts posterior probability, which is whether or not a patient will be alive at a point in time A from diagnosis D. It is calculated from the likelihood of observing the diagnosis among alive patients, which is this part right here. There's also the odds form of the naive Bayes formula, which uses death as a factor, which is shown by this, the A with the quotation mark. And this statement says that the odds of being alive is the product of the likelihood ratio of being alive, that's this part right here, multiplied by the prior odds of being alive, which is this part right here. So now we'll go into some of the SQL code for the team assignment. One of the first things that has you do is use the validation set of data. So in order to do that, you would just do the same thing we did last week with a training set of data, but instead of doing 0.8, you would just do 0.2 to get the 20% for the validation. For the actual questions, the first thing you want to do is determine the cutoff value by averaging 2 consecutive values. So the first block here, each row is given a value. The likelihood ratio is renamed as prob, and then that data is put into temporary table. I called it ordered data, and then ordered it by likelihood ratio. The next block here takes an average of the 2 consecutive values in the prob column and names it cutoff into a new table called cutoffs. And then it lists the cutoff values as 0 to 1. This next block here compares the cutoff to the predicted value. And if the predicted value is greater, then it's a value assigned of 1. Otherwise, it has a value assigned of 0. And then for the actual values, it looks at age of death. When age of death is null, it assigns a value of 0. Otherwise, assigns a value of 1. And that's into a table that I called temp1. We then calculate the sensitivity and specificity from the temp table. It shows the sensitivity as the sum of the actual values times the predicted values, and then it divides all of that by the actual value. The specificity, on the other hand, takes 1 minus the predicted value times 1 minus the actual value and divides that by the actual value. And then I made that into its own temporary table. So the next part is going to be finding the area under the curve. And this is going to be done through a series of trapezoids. The tops of the trapezoids are going to approximate the curve line. So here's one, and then another one would kind of like go that way. And all of these trapezoids are going to be made out of a triangle and a rectangle. So they're going to be two different calculations. The run, which is going to be the difference in the x's for the trapezoid, and the rise is going to be the difference in the y's. So in order to calculate the area of the triangle, on top is going to be rise times half of run. And then in order to calculate the rectangle is going to be run times the minimum height of the trapezoid. So looking at the code for this part, it will make a little bit more sense. The code takes specificity and sensitivity of adjacent data columns. It joins the table with itself and tells the computer to select the next row in the column. So it's looking at one row and then the next row and comparing them. So the first part here is looking at the rectangle, and it looks at the minimum sensitivity, which is found here, multiplied by the run, which is this part. And then the second part is the triangle, which is right here, and it takes half of the rise times the run. And then it just adds those two together to get the area. And then I again put that into just its own temporary table. So that is some of the code for the questions for the team assignment. And that is my presentation on the evaluation of SQL predictions. Thank you for watching my presentation.